Okay, finishing off here. Remember I always said you can't have roots in the denominator? Well, you can't have i's in the denominator either. So to get rid of i's in the denominator, I need to multiply the top and the bottom by something. And to do that, here's what I'm going to do. I'm going to multiply by the opposite here. Instead of 1 plus I, I'm going to multiply by 1 minus I. So what that means is 5 times 1 is 5. 5 times negative I is negative 5I. So that's what I have on top. On the bottom, 1 times 1 is 1. 1 times negative I is negative I. I times 1 is positive I. I times negative I is negative I squared. Here's why I did it. We know I squared is negative 1. So it's like me taking out the I squared and plugging in a negative 1. These actually cancel out. An I and a negative I cancel out. So really in the bottom I have 1 minus a negative 1, which is like saying 2. So really I have 5 minus 5I over 2 as my final answer. And there is no I in the bottom. With this problem, I take the opposite, so I multiply by negative 4I and negative 4I. So, negative 4I times 3, negative 12I. Negative 4I times negative 3I is positive 12I squared. Over 4I times negative 4I is negative 16I squared. And anywhere there's an I squared, that gives you negative 1. So 12 times negative 1 is negative 12. I have a negative 12I. And negative 16 times negative 1 is positive 16 on the bottom. And there is your answer. And I could pull out a 4 out of all of them, but we'll just leave it as that. Can't have root signs on the bottom, and I can't have i's on the bottom. So to get rid of this, I'd multiply by a 4 minus I root 3 and a 4 minus I root 3. So 4 times 4 is 16. 4 times negative I root 3 is negative 4I root 3. Negative I root 3 times 4 is another negative 4I root 3. And negative I root 3 times negative I root 3, well, a negative I times a negative I is a positive I squared. Root 3 times root 3 is 3. So, really, I have a 3I squared on top. And on the bottom, 4 times 4 is 16. 4 times negative I root 3 is negative 4I root 3. I root 3 times 4 is positive 4I root 3. I root 3 times negative I root 3 is root 3 times root 3 is 3. And since it's a negative, I squared, because I times negative I is negative I squared. Now once again, keep in mind, I squareds become negative 1s. So 16, and that's a negative 3, so it's a negative 13 with those gone. And negative 4I root 3 and negative 4I root 3 is negative 8I root 3. On the bottom, 16, and that's a positive 3, so that's 19. Negative 4I root 3's and positive 4I root 3's cancel, and there is your final answer. No problem. Finding the absolute value of complex numbers. Basically, all you do is you take the number squared, so it might be easier to see this one. The number squared, then the number in front of the I squared. You add them together and square root it. So it's like saying 1 plus 9 or root 10. Well, in this example here, it's like saying 0 minus 5i. So 0 squared plus negative 5 squared, and then the square root of it. So it's like saying square root of 0 plus 25. That's just like saying a square root of 25, which is 5. So those are the two answers for that problem. If you have any other further questions or concerns with complex numbers, please feel free to let me know. I hope I was able to answer all your questions.